So last class में हम लोगों ने structure of atom खत्म कर दिया है, atomic structure. Thankfully, now in many schools GOC is going on, but in some schools classification and periodicity is also going on. All right. So since it is already November, ideally we should start with the general organic chemistry, that is GOC, because you will have your end semester exams somewhere around in March. So either you must be doing equilibrium in your school, or you must be doing general organic chemistry, or if you are running a couple of months late, then you might have still been stuck on classification and periodicity. Now, according to the PACE syllabus, we have already done the first two chapters, that is mole concept and atomic structure. Let's today start and try to finish also with the third chapter, that is classification and periodicity. So although we will take help of the STEP app for this purpose, हम लोग STEP app में से, good afternoon, हम लोग STEP app की help लेंगे to finish this chapter. I will show you some videos on STEP app, and we will again play the true and false games, the questions which follow in STEP app. We will try and finish also this very chapter. It's a very small chapter. It has very less weightage also in the exams. So you will not feel that it has been rushed also. So in today's class, we will be taking up classification and periodicity of elements. All those who have done in their schools can take this class as a revision class and revise this particular chapter with me. Classification and periodicity, all those who have already done it, they can use this particular lecture for revision purposes. Now, first of all, what is the meaning of classification and what is the meaning of periodicity? So, you know, presently we have 118 elements in the periodic table. I'm sure you have all seen the periodic table, and that there are 118 elements presently in the periodic tables. If I show you the periodic table. So this is the periodic table, and presently you can see that there are a total of 118 elements in the periodic table, which are divided into different categories, which are divided into S block, P block. So these are the S block elements. These are all your S block elements. These are your all P block elements. These are known as P block elements. These central ones, these central ones are known as the D block elements, and these bottom ones, you all know, they are known as the F block elements, right? These are called the F block elements. That means the periodic table is actually divided into 4 blocks. We have the S block, the P block, the D block, as well as the F block. See, I will show you over here. First, there are 118 elements, and it was important to classify these 118 elements in a certain format. And the chosen format is this modern periodic table right in front of you, which divides these elements into very important 4 blocks, which are S block, P block, D block, and F block. Right? We have 4 blocks in which the elements are divided. And these blocks are again based on a certain criteria, which is the valence shell of your given atom, of your given element. But this modern periodic table was not the first attempt. Periodic table was not the very first attempt at classifying elements. If you think the modern periodic table was straight away given by scientists, that is not true. Earlier, there were many other attempts of making a different kind of classification of the elements present. That means scientists have been trying to classify, have been trying to group elements in a certain way so that their clarity, so that you are able to understand their reactions, so that you are able to predict their properties, and you are able to study group of elements together rather than studying 118 elements separately. And this attempt of classification we are going to find out in this particular chapter. How did we, after evolving through multiple attempts, finally reached the modern periodic table, which is in front of us? Second term, the meaning of the word periodicity. Second word is this periodicity. What is the meaning of periodicity? Periodicity when there is a repetition of properties after a certain interval. Repetition of properties after a certain time interval or a certain numeric interval is referred to as periodicity of properties. एक given period के बाद, एक given टाइम फ्रेम के बाद, इंटरवल के बाद अगर वही प्रॉपर्टी दोबारा रिपीट हो जाए तो उसे आप क्या कहेंगे? पीरियोडिसिटी कहेंगे. फॉर एग्जांपल, ये देखिए भाई, मेरे पास नोबल गैसेस प्रेजेंट हैं. सेकंड पोजीशन पर हीलियम है, ये रही पहली नोबल गैस. फिर 10th पोजीशन पर मेरे पास नियॉन है. जब मैं सेकंड से घूमकर 10th तक आई, the properties of helium and neon are same. I know that the properties of helium and neon are same. They are both noble gases. फिर मैं दोबारा 8 elements घूम के आर्गन तक आई, and I know again the properties of neon and argon are again same. कहने का मतलब है एक fixed interval के बाद when you reach a similar spot, the properties, the compounds, the reactions start to show repetition, start to show similarity, and this phenomena is known as periodicity of properties. So periodicity means when there is a repetition of properties after a given interval. Why is this periodicity important? Why do we have periodicity of properties? This is to study, it is to study the elements better. Periodicity in properties is done to study the given elements in a better way. Aye, let's see, let's take some help of wonderful step app that we have. We have all seen step app multiple times. Let's take help of this step app. All right, ready children? We will be trying to finish this particular chapter in today's class itself. That is why we are taking help of the video modules. First, I will show you some videos, then I will explain, and then I will ask you questions. All right, let's start.
One of the most outstanding contributions of the chemists of the 19th century was to classify chemical families. A German scientist, Doberliner, noted a similarity among the physical and chemical properties of several groups of three elements known as tribes. In each case, the middle element had the atomic weight about average of the atomic weights of the other two elements.
Okay, so the very first attempt that was made was by Daubigny. Now, this tells us that the first attempt made by any scientist was by Daubigny, and Daubigny classified groups of three triads. Three triads. Three triads means he made groups of three elements together based on a certain property called atomic mass. तो Daubigny ने क्या try करा कि मैं atomic mass वाला Sir, kindly please mute yourself. Anju from Nichar, please bacha mute yourself. Thank you. Okay. तो डॉबरने ने क्या ट्राई करा? एटॉमिक मास के बेसिस पर एलिमेंट्स को क्लासिफाई करा. He said that if I make groups of three elements, suppose A, B, and C, if the atomic mass of A is X, if the atomic mass of C is Y, then the atomic mass of B, according to Daubigny, should be X plus Y by 2. That is the average of the atomic mass of the first and the third element. And that was true. Whichever element he put in the center, the atomic mass came out to be the average of the first and third element only. Like that, he made groups of three elements, called it triads, and said that this is the classification according to me. So what you have to keep in mind? You have to keep in mind the criteria that Daubigny used. It was atomic mass. Now, again, going back to step up.
1866, the English scientist James correlated the atomic masses to their properties. He arranged the elements known at that time in an increasing order of their atomic masses and found that every eighth element has properties similar to those of the first.
All right. Beta, I hope the screen is visible. Nicha, please check on your other systems. I think the screen is visible. Bacha, please check on your systems, on your fellow systems. I'm sure the screen is visible. It's working fine because I've not been. Is blur. Screen is blur. Is anyone else facing a similar issue of blurred screen? I think the screen is clear. I will request you to please check your internet connectivity once. There might be some problem with the internet connectivity, right? It's clear, no? Okay, okay, it's clear. चलिए, let's continue. तो डॉबरनेल ने बोला कि भाई आप तीन elements का group बना लीजिए, but there was a problem with that not all elements can be classified into groups of 3 elements. कुछ ही ऐसे डॉबरनियर के ट्रायड बना पाए in which groups of 3 elements could be made. Apart from that, not all elements could be made into groups of 3 elements. आइए मैं आपको एग्जांपल से समझाती हूँ. It will be more clear to you. Can anyone in the group drop the names of triads? Those who बता दो का example दे. Help me out in this chapter. I know you've already done this chapter. Dumka, you have also, I think. Please let me know some examples of the Daubeney triads. देखिए, so Daubeney के triad कौन-कौन से थे? Example. Suppose he said that chlorine, bromine, and iodine should be put in one. He said that chlorine, bromine, and iodine should be put in one group. Now, the atomic masses of chlorine were at that time 35.5. Over here, 127. What will be the average of these two? What is the average of these two? Quickly, class 11th. Solve करिए and बताइए. 35. Let me see who answers first. Let's see who answers the fastest. Dumka, good afternoon. Start participating. हाँ, Nichar, very good. Excellent. तो ये ऐसा करो, आप लोग मुझे डायरेक्ट मैसेज करो. Okay, चलो, you can do it on the chat also. It's okay. I can see so many wonderful schools have connected. Please, everybody participate. Excellent. Okay. Barwani, Dondi, Dumka, Lafa. I want answers from all of the kids. Telangana, good afternoon. Shelty, how are you? EMRS Kaprada, answer de do. हाँ भाई. The average of these two will come out to be, some have given absolutely correct answers, 81.25. And if you find out, the atomic mass of bromine is also roughly around 81 units only. That means one triad could be very good. Telangana, excellent. Excellent. That means one triad could be this. One more triad example I'll give you. One more example of triad I'll give you. Lithium, he said sodium and potassium. Okay. So if I don't tell you sodium, lithium का atomic mass होता है 7, potassium का atomic mass होता है 39. What should be the atomic mass of this element? What should be the atomic mass of the central element? Yes, very good. Very good. Angel from Nichar, excellent. Angel and one more child, Sonal from Nichar, very good. हाँ भाई, Telangana, yes, absolutely, perfect. 23 element has atomic mass 23. Which element has atomic mass 23? Sodium. Sodium का atomic 3 होता है. तो क्या करा डॉबरनियर ने? एक और ट्रायड बना दिया. Like that, Daubeney made 3 triads, but unfortunately, all other elements could not be classified into groups of 3. Why? Because their atomic masses could not be put in such a combination of averages. That is why Daubeney's method had to fail. Then after which we went to the second method, that is Newland's law of octaves. And Newland said that, instead of making groups of 3, I will make of 8. I will make groups of 8 elements together. Again, I will arrange them in their increasing atomic masses only. They were all atomic masses. इसने भी क्या बोला? मैं elements को increasing atomic mass में arrange करूंगा. And you will see that after every 7th element, the 8th element will show properties similar to the first element. That means there will be a periodicity after every 8th element. Let's see from the video. You can see that he arranged elements in such a way. If see, if suppose lithium is the first element, then 8th element from lithium would be sodium, and we know lithium and sodium have similar properties. Again, 8th element from sodium will be potassium, और हम जानते हैं potassium और sodium के पास भी similar properties होती हैं. You can take any element. Suppose you take carbon. The 8th element from carbon will come out to be silicon, and we know carbon and silicon show similar properties. But then again, this method does not work. This method failed. Why? Because this method of a repetition of properties was only valid till calcium. After calcium, there was no repetition of properties at the 8th center. Let's see the video quickly.
Who related the atomic masses of elements to their properties. He arranged the elements known at that time in an increasing order of their atomic masses and found that every 8th element has properties similar to those of the first.
I hope language is not an issue. If anybody is facing problems,
The atomic mass as a standard and arranged 63 elements known at that time in an increasing order of their atomic masses. He found that the elements with similar properties repeat after a definite interval. Mendeleev left blank spaces where the properties of undiscovered elements were predicted by him. He showed that the valency of an element first increases and then decreases with respect to hydrogen and increases with respect to oxygen.
okay. हमने समझ लिया. न्यूलैंड also tried to make octaves, group of 8 elements. न्यूलैंड ने क्या करा? 8 एलिमेंट के ग्रुप बनाने शुरू करे और ये बोला कि हर 8वें एलिमेंट में प्रॉपर्टी रिपीट कर जाएगी. बट देन अगेन इट कुड नॉट वर्क आफ्टर कैल्शियम, मीनिंग only justified till calcium. It only justified the position of elements till calcium. That is why Newland's method also had to leave. Third attempt was done by Mendeleev. And Mendeleev is actually known as the father of modern periodic table. Mendeleev is given the true credit of Mendeleev and Moseley. Both of these are given the true credit of modern periodic table. Mendeleev का भी criteria क्या था? Again, atomic masses was his criteria. That is, he also arranged the elements in the increasing atomic masses. But he was very smart. He said he arranged them in a particular periodic format so that every element which showed similar property fell in the same column. So he said that my table will have two things. One, the vertical columns will be called periods. The vertical columns shall be known as periods. Groups. What am I doing? Groups. And the horizontal rows shall be called periods. So if suppose I am making this particular table, in this particular table there are 4 rows. So 4, 3, 2, 1. There are 4 periods and A, B, C. These are 3 groups. And he said that my elements will be positioned again according to their increasing atomic masses. Right? लेकिन देखो ध्यान से मेंडलीव की पीरियोडिक टेबल में भी दिक्कत थी. सुनते जाओ. This is a wonderful story of how we are going to make the periodic table. There have been multiple attempts by so many scientists throughout the years to finally give us the present modern periodic table, and it is so technical, it is so beautiful. that in the future also, if there are more elements discovered, they can be very easily accommodated into the present modern periodic table. It is so technical, it is so beautifully arranged that any element that is discovered after 118 elements can also be fit into the present table without altering the position of the remaining 118 elements. So obviously, such a wonderful, such a technical, such a calculated periodic table must have taken quite some time to make. Now, what happens is, let's see again. So this is the periodic table that Mendeleev proposed. Vertical groups, horizontal periods. He started with hydrogen. Hydrogen ke baad he found lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. After which he again went to sodium. He said, next element I will place over there. After the seventh element, eighth element will go over there. And finally, chlorine. Now remember over here, first thing. Noble gases were not introduced till this time. You can see fluorine ke baad there is no neon. Hydrogen ke baad there is no helium. Directly you have lithium. That means first thing, noble gases were not discovered. That is why they are not in the periodic table. Second thing you can see, there are certain gaps. There are certain gaps. You know, if he were to arrange the elements in increasing atomic masses, why put a gap? Calcium का atomic mass था 40, उसके बाद directly he should have put titanium because that was the element available with the next largest mass. But he said no. No. He said the properties should also match, and the properties of aluminium and titanium don't match. That is why very smartly Mendeleev left gaps, and not only he left gaps, he also predicted the properties of these elements. The Mendeleev's idea of periodic table was so ahead of his time that not only he left gaps, he also predicted what kind of an element this would be. He named it, he called it Eka aluminium, Eka boron, because these elements fell right below one another. And he gave their melting point, he gave their boiling point, density, he gave a rough atomic masses. And in future, when these elements were actually discovered, they were found to have exactly similar properties to that of Mendeleev's. You will find them written in your NCERT. But there was one mistake. Listen, look carefully. If you see over here in the Mendeleev's periodic table, iron, cobalt, and nickel. Iron atomic mass 55.9. Cobalt atomic mass 58.9. Nickel atomic mass 58.7. So if I were to arrange my elements in increasing atomic masses, I should have, what happened, Nichar? Nichar, is everything okay? Ideally, I should have done nickel pehle aana chahiye tha cobalt se, but he again on purpose did this mistake because he had to match properties of cobalt with rhodium. Second, you can see tellurium and iodine over here. If you have NCERTs close to you, please look in the NCERT. आप देखेंगे tellurium और iodine. Tellurium atomic mass 128. Iodine atomic mass 127. Again, he shifted their positions. He interchanged their positions. Iodine इधर कर दिया, tellurium आगे कर दिया. So Mendeleev made sure that even if he has to make certain mistakes, the properties of elements should remain constant. One more module and then questions. All right.
In this slide, we will discuss about Moseley law. Henry Moseley observed regularities in the characteristic X-ray spectra of the elements. A plot of V, frequency of X-rays emitted, against atomic number Z gave a straight line. He therefore that the atomic number is a more fundamental property of an element than its atomic mass.
All right. Now, like I told you, both Moseley and Mendeleev are actually credited to be the father of modern periodic table. Moseley was the scientist who, after the attempts of Mendeleev, gave us a very revealing experiment. So what Moseley did is that he measured certain physical properties such as X-ray emissions of the given elements. And that is when Moseley found out that the property is actually changing not according to the atomic mass, but according to the atomic number. तो अब तक जो भी साइंटिस्ट ये गलती करते आ रहे थे, whether it was Daubeney or Newland or Mendeleev, they were all arranging the elements based on atomic masses. चाहे आपके पास डॉबर्नियर थे या न्यूलैंड थे या मेंडलीव थे, ये सारे ही एलिमेंट्स को एटॉमिक मासेस के हिसाब से अरेंज करते आ रहे थे. बट नाउ इट बिकेम क्लियर, अब मोजले के एक्सपेरिमेंट से समझ में आया, मोजले ने ये एक्सरे एमिशन का एक्सपेरिमेंट करा और अपने को समझ में आया कि प्रॉपर्टी एक्चुअल में एटॉमिक मास के हिसाब से नहीं वैरी कर रही. फिजिकल या कोई भी केमिकल प्रॉपर्टी एटॉमिक नंबर के हिसाब से वैरी कर रही है, and that actually laid the foundation for a modern periodic table. Now class 11th and their respective coordinators, I want all of you very ready, be please ready on your systems because we will be starting with question answer round. Okay, जल्दी जल्दी आप लोग आंसर करेंगे ट्रू एंड फॉल्स का, मैं आपको क्वेश्चन हिंदी में ट्रांसलेट कर दूंगी. All right, I'm starting. First question, let's get ready to answer. Sulfur, selenium and tellurium are an example of Daubeney's triad. मैंने आपको दो एग्जाम्पल दिए. क्या सल्फर, सिलीनियम और टेलुरियम को डॉबर्नियर ने एक ट्रायड में बताया था? ट्रू और फॉल्स? ओके, आंसर्स एक्सीलेंट. क्विकली लेट्स सी आंसर्स फास्टेस्ट. भाई एक ये बारिश से आंसर आया है, अनुपुर से ट्रू कह रहे हैं. ओहो अनुपुर दोबारा देखो बेटा एक बारी. निचार से फॉल्स. ओके, हु एल्स? जल्दी जल्दी क्लास 11th, जल्दी क्लास 11th, 30 seconds are left. Arihant, which EMRS you are from? Angel and Sonal are also saying false. Okay. Okay, Anupur, I need you to go ahead and check your answer once. Quickly, 10 seconds. I should go with false. So Anupur, actually your answer was correct. Sulfur, selenium and tellurium, they do form a Daubeney triad. Quickly, class 11, please note this example down wherever you are noting down. दुमका नहीं, हाँ अनुपुर ट्रू ही है, बिल्कुल सही, ट्रू ही है. एब्सोल्युटली करेक्ट. बेटा जी, जिन जिन को नहीं मालूम था ये बात, प्लीज नोट कर लीजिए. सल्फर, सेलेनियम एंड टेलुरियम, दे आर आल्सो अ पार्ट ऑफ डॉबेनियर्स ट्रायड. ओके, let's see next question. Daubeney law was applicable to all the elements in the halogen family. Halogen family, फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन, क्या इन सभी पर डॉबर्नियर का ट्रायड एप्लीकेबल है? ट्रू या फॉल्स? अनुपुर, या वेलकम. ये बताइए, अब ये बताओ जल्दी से. बेटा ये EMRS, ये पक्का, ये इतना सारा टी जो आ रहा है, which EMRS are you from? Is this Pragati from Nichar? Okay, somebody in Nichar is saying false, someone else is saying true. Dumka says true. Okay, Pragati. All right. देखो, I am going with Dumka's answer today. Who else? Who else? निचार is split. निचार नहीं समझ पा रहा, या तो ट्रू करना है या फॉल्स करना है. अरिहंत बेटा कौन से हमारे से हैं आप? 5 seconds. I am going with true. Again. Fluorine does not fall in the Daubeney's triad. I had written the example, fluorine, bromine and iodine. Chlorine, bromine and iodine. Fluorine does not fall in the class of triads. Fluorine को अगर आपने atomic mass ले लिया तो वो नहीं देगा. अच्छा भाई, ये चेक करो जल्दी जल्दी चेक कर दो. Phosphorus, arsenic and antimony, Sb, obey Daubeney's law of triads. Quickly, he's given you the atomic masses. Check करके बताओ. Phosphorus 31, arsenic 75, Sb 122. Are they obeying the atomic Daubeney's triad? Okay, Anupur says false. Okay, Pragati says true. Angel and Sonal are saying false. I'm going with Anupur's answer. Okay, Nichar, आधे बच्चे false कह रहे हैं. Who else? Telangana, where are you? Marimadla, where are you? Dumka, where are you? Okay, Rati Kanta is saying true. Ma'am, which EMRS are you from? Rati, ma'am, which EMRS? Acha, okay, Arihant is from Telangana only. Perfect. I am going with Arhan's answer. He's saying false. False कहाँ से हो रहा है? इनका एटॉमिक मास मैच नहीं कर रहे. 31 प्लस 122 153 153 75 बैठ नहीं रहा लगभग लगभग 150 के आसपास. अम्बस्सा. ओके ओके मैम, रति मैम. ओके, तुमका अब क्या फायदा, इन्होंने गलत करवा दिया. अगेन यू विल प्ले. ओके, क्विकली लेट्स सी वंस मोर टाइम. अब ये बताओ, लिथियम सोडियम एंड पोटेशियम दे फॉर्म अ डॉबनियस ट्राइड. ट्रू एंड फॉल्स, वी नो दिस. ट्रू. 76.5 था बेटा, 76.5 चल जाता, कोई बात नहीं. ओके, बाय दिस टाइम आई एम गोइंग विद अनुपुर's आंसर ओनली. दुमका, व्हाट डू यू से? शैल आई गो विद ट्रू और फॉल्स? ट्रू कह रहा है, चलो ट्रू कर लेते हैं. परफेक्ट, वेरी गुड, बोथ दुमका एंड अनुपुर, वेरी गुड. Newlands arranged the elements in increasing order of atomic masses, found that every eighth element has properties dissimilar to those of the first. Dissimilar to those of the first. False. Very good, Anupur. Excellent. Rati ma'am, where are you? AMRS Ambassa, where are you? Arihant, where is your answer? Dumka keh raha hai false. Let's go with false. Perfect. Excellent. Very good. Agla. Mendeleev arranged the elements in increasing order of atomic numbers. True or false? Angel, Sonal, Pragati, गड़बड़, सबकी गड़बड़ हो रही है. अरिहंस, आप बता दो. Very good, Ambassa. I am going with Rati ma'am's answer. I am going with Rati ma'am's answer. She is saying false because मेंडलीव ने एटॉमिक नंबर नहीं, एटॉमिक मास के हिसाब से अरेंज किया था. एटॉमिक नंबर सिर्फ मॉडर्न पीरियोडिक टेबल में है. वेरी गुड, एक्सीलेंट. अगला सवाल. मोस्ले कंक्लूडेड दैट द एटॉमिक मास ऑफ एन एलिमेंट इज द मोस्ट फंडामेंटल प्रॉपर्टी ऑफ एन एटम. मोस्ले ने ये बोला कि एक एटम की मोस्ट फंडामेंटल प्रॉपर्टी उसका एटॉमिक मास है. ट्रू या फॉल्स? दुमका कह रहा है फॉल्स, अनुपुर कह रहा है फॉल्स, निचार कह रहा है फॉल्स, अंबसा कह रहा है फॉल्स. वेरी गुड, वेरी गुड, वेरी गुड. मोर, आई नीड मोर पार्टिसिपेशन, जिससे मुझे पता लगे कि सबके समझ में आया है. ठीक है भाई, वेरी गुड. डोंडी, बरवानी, लाफा, लाहौल, लहुनीपारा, वेर आर यू? वेर इज लाफा एंड लहुनीपारा? फॉल्स. एब्सोल्युटली करेक्ट. चलो, इस बार का थोड़ा बेटर था. लेट्स सी द नेक्स्ट कॉन्सेप्ट, द मॉडर्न पीरियोडिक टेबल.
In this slide, we will discuss about long-form periodic table. It is based on electronic configuration proposed by Bohr, Berry, and others and is known as long-form periodic table or Bohr table. It comprises of 7 horizontal rows called periods and 18 vertical columns called groups. The period number indicates the number of shells present in the element.
All right. This is we are finally made the modern periodic table. And the characteristics of modern periodic table are, first, they are based on atomic number. अब आप जानते हो हाइड्रोजन, हीलियम, लिथियम, बेरिलियम, इनको इंक्रीजिंग एटॉमिक नंबर में आप अरेंज करते जाइए. यू विल गो टुवर्ड्स मेकिंग द मॉडर्न पीरियोडिक टेबल. It has 7 periods and the number of each period tells us the number of the valence shell. वैलेंस शेल से मैं आपको लास्ट क्लास में, लास्ट चैप्टर में मिलवा चुकी हूँ. वैलेंस मीन्स आउटर मोस्ट शेल, आउटर मोस्ट हाईएस्ट शेल ऑफ दैट पर्टिकुलर एटम. तो पीरियोडिक नंबर हमें बताता है वैलेंस शेल के बारे में. देयर आर 7 पीरियड्स, देयर आर 18 ग्रुप्स इन द मॉडर्न पीरियोडिक टेबल. मूविंग ऑन.
Numbered as group 1 to 18. In the diagram. in which the group 18 was called as group 0 or group A.
Okay, so basically they have shown the older names of groups also. They have taken these names from Mendeleev's table. तो मेंडलीव के टेबल में अगर मान लो 8B जो था वो मॉडर्न टेबल में 10th ग्रुप का काम कर रहा है. मेंडलीव के टेबल में जो नोबल गैस का ग्रुप था वो 0th ग्रुप था, 0 सबसे पहले वाला. लेकिन मॉडर्न टेबल में वही सबसे आखिरी का ग्रुप बन गया, लास्ट वाला ग्रुप, विच इज ग्रुप 18. मूविंग ऑन.
Elements of subgroup A, that is, of 1A, 2A, 3A, 4A, 5A, 6A, and 7A are known as main group elements or representative elements or the normal elements. These elements have their outermost shell incomplete. Elements in the zero group to their stable electronic configuration. They hardly react with other elements.
All right. So we have one term called representative elements. What is the meaning of representative elements? Elements of S block. ये देखो ये पूरा S block था. ये वाला S block elements है first two groups. और ये बाकी के सारे P block from group 13 to group 17. They are together known as representative elements. There is no logic behind that. They're just called representative elements. All right. Next.
For the groups 3 to 12, they have their 2 or 3 outermost shells incomplete. All these are metals which generally have high melting and boiling points. Elements of group numbers 3 to 11 are known as transition elements.
Okay, so the D block elements which lie from group 3 to group 12, 3 से 12 तक के जो elements हैं, they are called D block elements. और elements from 3 to 11 are called transition elements. Please children, don't make this mistake. Sometimes this question is asked. Elements from group 3 to 12 all are called D block elements, right? But elements from 3 to 11th group are called transition elements. Only these are called transition elements. Right? Then the F block elements, they are also called inner transition elements. Why they are called inner transition? We'll have a discussion about that also. But as of right now, please make sure you know that only 3 to 12 are called D block, 3 to 11 are called transition. Means that group 12 जिसके अंदर कौन आ रहा है, जिंक आ रहा है, कैडमियम आ रहा है और मर्करी आ रहा है. जिंक, कैडमियम, CD एंड Hg, मर्करी. इनके नाम में लिख दे रही हूँ आप. कैडमियम, मर्करी. These three elements, they are only called D block elements. They are not called transition elements. चलिए वापस देखते हैं. What else? Now questions again. Ready? Question answers again. Ready everybody? True and false. I'm playing the game. First question. Vertical columns are called groups. True or false? Vertical columns are called groups. True. Easy question है ये तो. Very easy question it is. है ना? हाँ, very easy. Rati ma'am, absolutely right. Let's go with true. Absolutely correct. Next, according to IUPAC recommendation, group 4A in the older notation is numbered as group 4 in the new notation. This is a difficult question. This is a difficult question. वो कह रहा है कि मेंडलीव के टेबल में जो 4A था, क्या मेन पीरियोडिक टेबल में वही ग्रुप 4 है? Also says true. I hope you are saying true to this question only, not the previous one. निचार भी ट्रू कह रहा है, तेलंगाना भी ट्रू कह रहा है, ठीक है. आई एम गोइंग विद तेलंगाना's answer. Oh no. 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 It is replaced with group 14. It is replaced with group 14. So 4 in the Mendeleev's table is actually 14 in the modern table. Please keep your NCRTs open at both the Mendeleev's periodic table as well as main periodic table. You will find the difference, right? Okay, let's do once again. All elements of the 6th group have 6 shells. True or false? Okay, Dumka says false. Pragati says false. Pragati इसी का कह रहे हो ना? तो फिर जल्दी बताओ किसका? अनुभुर says true. अनुभुर ये तुम गलत करवाओगे? अनुभुर ये तुम गलत करवाओगे? दुमका कह रहा है false. ठीक है? अंबसा, okay. Marimatla is also saying false. Absolutely. भाई सारे एलिमेंट्स में 6 शेल होंगे जरूरी थोड़ी है. फर्स्ट ग्रुप में फर्स्ट एलिमेंट में एक ही शेल होगा, दूसरे एलिमेंट में एक से ज्यादा शेल होंगे, छठे पीरियड के एलिमेंट में जाके 6 शेल होंगे. यस और नो? सो फॉल्स. वेरी गुड. अकॉर्डिंग टू आयुबैक ग्रुप 5A, आप गलती नहीं करोगे. 5A is numbered as group 15 in the new notation. True or false? True. Yes. Yes. अब वो वाली गलती नहीं करोगे आप दोबारा से. Group 5A in the Mendeleev's table is 15 in the modern table. True and false? Very good. I'm going with true. Absolutely correct. Next. Group 4 elements are representative elements. Group 4 के elements. जल्दी से सोच लो which elements are in the group 4. Remember. Ambasa is saying false. Nichar is saying false. तेलंगाना गड़बड़ हो जाएगी. मारीमडला गड़बड़ हो जाएगी. I want to answer quickly. Lahul, where is Lahul today? Lahunipara and Lafa. Where are these 3 EMRSs? Come on, answer quickly. Okay, Dumka is saying false. बेटा ग्रुप 4 के एलिमेंट्स कौन से हैं? फर्स्ट के हो गए लिथियम वाला, सेकंड हो गया बेरिलियम मैग्नीशियम वाला, थर्ड हो गया स्कैंडियम वाला, फोर्थ हो गया टाइटेनियम वाला. तो इसके अंदर दीज आर नॉट रिप्रेजेंटेटिव एलिमेंट्स. फॉल्स. एलिमेंट्स ऑफ ग्रुप नंबर 3 to 11 are called transition elements. ये बात मैंने आपको अभी क्लियर करी है. 3 to 11 are called transition elements. True or false? भी अभी क्लियर करी है. वेरी गुड. सारवार बिल्कुल ठीक कह रहे हो आप भी. वेरी गुड. ट्रू. एक्सीलेंट. चलिए अगला कॉन्सेप्ट देखते हैं. लेट्स सी सम मोर प्रॉपर्टीज अबाउट द मॉडर्न पीरियोडिक टेबल.
Are called periods. Elements with electrons increasing arithmetically in their outermost shell, that is, one by one, till an octet is attained, are placed in the same period. The first period contains only 2 elements.
I believe the screen had gone for a brief second. हाँ मारिमट अरिहंत आप जो भी कह रहे हो वो बिल्कुल ठीक कह रहे हो. दे आर कॉल्ड रिप्रेजेंटेटिव एलिमेंट्स. अब स्क्रीन आ गई है वापस. ठीक है. चलिए मैं दोबारा दिखा देती हूँ आपको ये वाला स्लाइड.
Only 2 elements. Hence, it is the shortest period.
So he's saying basically that there are certain groups and there are certain periods. First period only has 2 elements. That is why it's the shortest period known. Moving on.
Second and third periods contain 8 elements each, atomic numbers 3 to 10 in the second and atomic numbers 11 to 18 in the third period. These are short periods. The fourth and fifth periods contain 18 elements each. Atomic number 19 to 36 in fourth and atomic numbers 37 to 54 in the fifth period. These are long periods.
Okay, so basically he's saying that first period only has 2 elements, right? You see period number 1 only has hydrogen and helium. So this is called the short period. No, this is called the very short period, I think. Wait.
Each atomic numbers 3 to 10 in the second and atomic numbers 11 to 18 in the third period. These are short periods.
And these are short periods, okay? So this is the very short period. Then second and third period, this is the short period. Short period, because they have how many elements each? 8 elements each. Then 4, 5 have 18 elements each. That is why they are called the long periods. They're also called the long periods. Now let's see remaining.
The sixth period contains 32 elements, atomic numbers 55 to 86. It is the longest period. The seventh period, atomic numbers 87 to 118, also contains 32 elements, many of which are man-made elements.
So the last two, 6th and 7th, since they have 32 elements each. अब आपको 32 यहाँ दिख नहीं रहे हैं, but if I show you these, the first row of lanthanoids from CE to LU are also in the 6th period, right behind lanthanum. These elements are also, these 10, 11 elements are also a part of 6th period only. They are falling right behind lanthanum. Similarly, from thorium to lawrencium, again, they are falling right behind actinium. So these two elements, so this first pink colored row is actually a part of the 6th period, and this second pink colored row is a part of the 7th period. All right, that is why they are called the longest periods. Moving on.
In group 3 of the 6th period, there is a set of 14 elements with atomic numbers 58 to 71, which are known as lanthanides. In group 3 of the 7th period, there is a set of 14 elements with atomic numbers 90 to 103, which are known as actinides.
That is what I'm telling you. This is how you will see the 32 elements in the 6th and the 7th period. All right, ready everyone for the questions now? Shall I start? Chaliye bhai, I'm starting the questions. All right, first question. Let's go. 3, 2, and 1. First question. There are 6 periods in the periodic table. Easy. There are 6 periods in the periodic table. No? No 7? Yes. हाँ दोंडी बिल्कुल सही. I am going with दोंडी छत्तीसगढ़'s answer. No, there are not. बता दो छत्तीसगढ़, जल्दी से बता दो. How many periods there are? दोंडी, दुमका, लाहुल, very good. दोंडी जल्दी से बता दो. How many periods there are then? If not 6. Very good. False. बिल्कुल सही. Perfect. Next. Element with atomic numbers 3 to 10 are placed in the second period. Atomic number 3 to 10 in the second period. True or false? 3 atomic number किसका है? लिथियम का. 10 किसका है? नियॉन का. लिथियम से नियॉन तक कौन से पीरियड में आते हैं? ट्रू. ट्रू. तेलंगाना, वेरी गुड. लाहुल, yes, true, absolutely. It contains 32 elements. True or false? 6th period, does it contain 32 elements? True or false? अल्ले गड़बड़ हो जाएगी. No, it does not contain 52. No. Okay, Arihant is saying true. Ambasa is saying also true. ठीक है भाई. Yes, beta, it contains 32. These are called the longest periods, right? Very good. In actinide series, there are 14 elements. एक्टिनाइड याद करिए, एक्टिनाइड कौन सी थी? जो नीचे बॉटम में 2 पिंक कलर के रोज बने हुए थे, उसमें से जो सेकंड वाला रो था आर कॉल्ड एक्टिनाइड. आर देयर 14 एलिमेंट्स प्रेजेंट? दुमका सेज ट्रू, लाहुल सेज ट्रू. ओके. डोंडी, व्हाट डज डोंडी से? Ambasa is also saying true. Okay. Telangana is also saying true. ठीक है. Lahunipara, where are you? Dumka says true. I'm going with true only. Absolutely correct. क्या बात है? 100% accuracy. Very good. Excellent. Next. Valency and the position of elements.
Number of shells increases down a group and number of valence electrons. From left to right in a period, number of shells remains same and number of valence electrons increases. The number of valence electrons for S block is equal to -10.
Very simple. He's saying that in the same period, the valency will keep on increasing, remain same. एक पीरियड में शेल नंबर सेम रहेगा. मान लो मैं थर्ड पीरियड की बात कर रही हूँ, सभी एलिमेंट्स में वैलेंस इलेक्ट्रॉन थर्ड शेल में ही जाएगा, बट देयर नंबर ऑफ वैलेंस इलेक्ट्रॉन्स विल कीप ऑन इंक्रीजिंग. एक ग्रुप में valence shell will keep on changing, but the valence electron will remain same. भाई लिथियम का, सोडियम का, पोटेशियम का, रुबिडियम का, इन सब का number of outermost electron will remain same, but the shell keep on changing, right? S ब्लॉक की वैलेंसी क्या होती है? S ब्लॉक की वैलेंसी होती है उसका ग्रुप नंबर. सपोज आपसे पूछ रहा है व्हाट इज द वैलेंसी ऑफ सोडियम, सो सोडियम का ग्रुप नंबर इज 1. What is the valency of suppose aluminium? So for p block elements, the valency will be group number -10. So if you have group number 15, so valency would come out to be group number 15 minus 10, that is 5. And that's true. Phosphorus, arsenic, they all show valencies up to 5 also, right? Let's see.
Here we will discuss about valency. Valency of an element, the number of valence electrons gained or lost or shared when it combines with another element. Elements in a particular group have equal number of valence electrons. Valency remains the same.
Okay, so you just have to know how to find valency. You all have done this in the junior classes also. If valency basically means 8 minus number of valence electrons, right? Let's see. Beta, please don't, Gaurav and Aditya from HR, please don't.
Character increases down a group due to which oxides of elements become increasingly basic in character. From left to right in a period, metallic character decreases and oxides of elements in a period become progressively less basic and gradually become acidic in character.
Okay, so he's saying that let's compare the metallic and the non-metallic character. On going down the group, metallic character बढ़ता है, ज्यादा होता है, increase होता है. यानी कि अगर मैं सोडियम और सीजियम में कंपेयर करूं तो सोडियम will be less metallic than cesium. But on going from left to right, the metallic character decreases. क्यों? आप जानते हैं इस तरफ metals हैं, इस तरफ non metals हैं, तो जितना आप left से right जाते जाएंगे, the metallic character will keep on lowering, will keep on decreasing, and non metallic character will keep on increasing. Now the oxides of metals are all basic in nature. Oxides माने भाई मान लो सपोज आप एग्जांपल दे देती हूँ मैं आपको MgO. ऑक्साइड क्या है? एक मेटल का ऑक्साइड है. इट इज बेसिक इन नेचर, बट ऑक्साइड ऑफ नॉन मेटल्स दे आर इंक्रीजिंगली एसिडिक इन नेचर और दे आर इंक्रीजिंगली न्यूट्रल इन नेचर. फॉर एग्जांपल N2O5 ले लो. मान लो नाइट्रोजन का जो ऑक्साइड है, नाइट्रोजन मेक्स लॉट्स ऑफ ऑक्साइड्स, दे आर आइदर न्यूट्रल और एसिडिक इन नेचर. सो ऑलवेज non-metallic oxides will be acidic in nature, major, and metallic oxides majorly known to be basic nature. Continuing, moving on.
The position of an element, we have to check the period of an element, which relates to the number of shells present, and the group number is related to the number of valence electrons present. Number is equal to the principal quantum number of the valence shell.
तो ये क्या कह रहा है कि बेसिकली आप पीरियड नंबर से क्या इंफॉर्मेशन निकाल सकते हैं? शेल नंबर. और ग्रुप नंबर से आप क्या इंफॉर्मेशन निकाल सकते हैं? अगर एस ब्लॉक का एलिमेंट है तो उसका ग्रुप नंबर उसके बैलेंस इलेक्ट्रॉन के बराबर होगा. अगर पी ब्लॉक का है तो बैलेंस इलेक्ट्रॉन्स में कितने वैलेंस शेल में कितने इलेक्ट्रॉन है प्लस उसका 10 कर दीजिए, दैट्स हाउ यू कैन फाइंड आउट द ग्रुप नंबर. डी के लिए n-1d मतलब एक तो ns वैलेंस शेल, एक वैलेंस से पहले वाला दैट इज पेनल्टीमेट शेल. दोनों के नंबर ऑफ इलेक्ट्रॉन्स ऐड कर दीजिए, दोनों के टोटल नंबर ऑफ इलेक्ट्रॉन्स ऐड कर दीजिए, यू विल गेट द नंबर. For F block elements, always all the F block elements fall in the third group. देखा था हमने lanthanum और actinium के पीछे, they were all lying, they all lie in the third group only. All right, ready now? Let's play. Let's play. Question number 1 on your screens in a. Okay, question number 1. Number of shell increases on moving down the group. नंबर ऑफ शेल जैसे जैसे आप ग्रुप में नीचे जाते जाते हैं इट कीप्स ऑन इंक्रीजिंग. हाँ भाई, वेरी गुड, आई एम गेटिंग आंसर्स. अंबसा आल्सो गुड, डोंडी वेरी गुड. इट कीप्स ऑन इंक्रीजिंग, वी नो दिस. Lahore also very good. Okay, I'm going with true. Very good. Absolutely correct. Next. The group element of group 13 shows a valency of 4. Group 13 के elements कौन से हैं? Are the elements of group 13? Do they show valency 4? Valency कैसे निकाल? Ambasa is okay, very good. Dondi also absolutely correct. Ambasa also very good. Who else? निचार वेरी गुड. निचार गर्भ, हाँ ठीक है. दुमका सही कह रहे हो बिल्कुल, वेरी गुड. 3 वैलेंसी, यस अरिहंत, परफेक्ट. बाय फॉल्स. हैलोजन फॉर्म्स एसिडिक ऑक्साइड. हैलोजन कौन से थे? फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन. द ग्रुप 17 एलिमेंट्स. What will be the nature of their oxides? True. Very good. Very good. I want answers from everybody. Lahul, very good. भाई जैसे जैसे आप लेफ्ट से राइट जाते जाएंगे, the of the oxide will keep on increasing. Very good. Element scandium, atomic number 21, lies in the 4th period. Atomic number 21 lies in the 4th period. False. Scandium की कॉन्फ़िगरेशन लिख के देखिए. एटॉमिक नंबर 21 की कॉन्फ़िगरेशन लिख के देखिए. हाँ बिल्कुल, डोंडी भी सही कह रहा है, अंबसा भी सही कह रहा है. लाहुल आंसर बता दो इसका. लहू ने पारा आप बता दो. व्हाट विल बी दी ग्रुप, व्हाट विल बी द पीरियड नंबर ऑफ स्कैंडियम? दुमका ट्रू. ट्रू, वेरी गुड, एब्सोल्युटली करेक्ट, वेरी गुड. Accuracy 100%. D block element. Very good, Lahul. A good big round of applause for the kids who participated. 100% accuracy. बिल्कुल सही जवाब सभी के. Next concept. Next concept. The 4 blocks. Remember I had 4 blocks. S block, P block, D block and F block. Let's learn about the blocks now.
An important feature of the long form of periodic table is its division into 4 sections known as S, P, D and F block elements. The S, D and F block consist of metals. The P block consists of metals, non-metals and metalloids.
Now we are basically, अभी तक हमने अपना periodic table divide किया था based on number of groups या number of periods, right? या अब हमने पहले divide किया था based on metals और non-metals. Now we are dividing the periodic table based on the blocks. S block, P block, D block or F block. Now majorly S block, all S block elements are metals, all P block elements are also metals and all F block elements are also metals. In the P block, that is the last part of periodic table, there are some very few elements which are metal. some which are non-metal, metalloids. Metalloids lie between metals and non-metals, and remaining are all non-metals. Let's see more information.
Discuss about S and P block elements. Groups 1 to 2 S block consists of reactive metals with fixed valency. Alkali metals 1 are the most reactive metals. Groups 13 to 18 form P block. Many elements of P block show variable valency. Halogens, group 17, are the most reactive non-metals.
Okay, so he has told about certain elements. You can see white color blocks are known as representative elements. Yellow color blocks are called transition elements. Green color blocks are called inner transition elements. Remember, I had told you F block elements are also called inner. By inner, they are lying inside the D block, right? Separately, they are lying inside the transition elements only. That is why we have named them as inner transition elements. And the red ones, they are non-metals, or sorry, noble gases. Moving on.
Discuss about D block elements. Groups 3 to 12 form D block. All these elements are metals with high melting and boiling points and are good conductors of heat and electricity. Some of these elements are attracted towards a magnet. Most of these elements exhibit variable valency and form colored compounds.
So transition elements are called transition because they have variable valency. They have variable oxidation state. In the case of S block elements, the valency is fixed. That will be the number of their group. अगर group number 1 है तो valency 1. Group number 2 है तो valency 2. But in case of similarly in case of P block elements also the valency is fixed. It will be group number -10. But in case of the transition elements, that is from groups 3 to 11, they have variable valencies, they have a variable oxidation state. That is why their properties keep on transiting, keep on shifting between S block and P block elements. That is why they are called transition elements. Moving on.
Here we will discuss about F block elements. The F block consists of lanthanides from atomic number 58 to 71 and actinides from atomic number 90 to 103. All these belong to group 3 of the periodic table. These elements are heavy metals with high melting point and boiling point and generally show a valency of 3. Some elements also show valency of 2 or 4.
Okay. So now we have discussed about the F block elements also. They have a general valency of 3. They are heavy metals. They are most of the times all the F block, majorly F block elements except till uranium, they are all man-made. They are all artificially synthesized. And their common oxidation, common valency is 3. But in some cases, they also show valencies of +2 or +4. All right, ready now? Questions are coming. Questions are coming your way, class 11. Question number 1. Element of S block are non-metals. True or false? Elements of S block are non-metals. False. Okay, I have answers from Lahul also, Dumka also, Nichar, Ambasa also has answered. Telangana, where are you? Dondi, where are you? Telangana, Dondi, where are you? What are your answers? Please participate. दुमका अच्छा दुमका ने तो आंसर कर दिया सॉरी गमनोम Anupur, where is Anupur? But this is false. They are actually metals. And halogens are the most reactive non-metals. True or false? Halogens are the most reactive non-metals. Is this statement true? I think this is a very easy statement. False. Nichar is saying false. Dumka, true. Very good. Very good. Lahul, very good. Anupur, where are you? वो कह रहा है कि हैलोजन सबसे ज्यादा रिएक्टिव नॉन मेटल्स होते हैं. पहली बात, हैलोजन नॉन मेटल तो होते ही हैं. दूसरी बात, रिएक्टिव होते हैं कि नहीं? तो बिल्कुल सही बात है, दे आर मोस्ट रिएक्टिव. ट्रू. Most of the metals have fixed valency. True or false? Remember, I told you that d block elements or transition elements are called a transition because they don't have fixed valencies. False, Ambasa, very good. Tumka says false. Okay. There is Anish and Rohan from Nichar. Arihant, what do we think? Dumka says false. Okay. Lahul, do D block elements have fixed valencies? Fixed valency किसकी होती है? S block की होती है और P block की होती है. D block वालों की fixed valency नहीं होती. False. Then all F block elements belong to group 4. 4 या something else. सारे F block elements fourth group में आते हैं या किसी और group में? जल्दी बताओ. हरियाणा किसका? From Telangana, please tell me the answer of this question. Fourth group or some other group? Dumka says false. Very good. Dondi, what do we think the answer is? Dondi says false. कौन से group? False. Then also tell. Arihan, जल्दी से बता दो. Then which group they fall into? डोंडी बिल्कुल सही बता रहे हो. कौन से ग्रुप में आता है? The third group. Very good. They fall in the third group. Again, 100% accuracy. All the EMRSs who have participated, 100% accuracy. Excellent. Next concept, nuclear charge.
We'll discuss about the effective nuclear charge. It is the effective units of effective charge experienced by an electron, taking into account the inter-electronic repulsion in a multi-electron species. The Z effective is calculated by using the equation given.
Effective nuclear charge basically क्या होता है? It is that एक nucleus है, nucleus is attracting the valence electron. एक nucleus है जो valence बाहर के electron को attract कर रहा है. That is the pull of nucleus toward the valence electron. But ये जितने भी बीच के electrons हैं, see again, if you see the diagram, suppose this is the valence electron which is being pulled inside by nucleus. पर ये जो बीच के electrons हैं, they will create repulsion between the valence electron and themselves, which will act like a shield. So these actually start the valence electron from the nucleus, and that is why the total nuclear pull is not phased by the valence electron. This leads to a new much effective. Then how much nuclear charge is phased? It is known as the effective nuclear charge. Moving on.
Gives rules for calculating the shielding constant. Firstly, the electrons are arranged in a sequence of group. For an electron of NS or P group, use the following rule.
Okay, we don't have to do this. The Slater's rule part is not there. We can leave this part. Let's see this part. Radii.
The atomic radius is of three types. These are first, covalent radius, second, van der Waals radius, and third, metallic radius. The atomic radius between van der Waals radius greater than metallic radius greater than covalent radius.
So basically, there are three types of radius exist. What are these three types? So if a bond is formed between two metal, between a metal and a non-metal, positive charge, chlorine with a negative charge. Then the effect in these atoms will be called the ionic radii. We will call this the ionic radii, the radius which is formed between two ions by gaining electrons. Then suppose there is a compound of, say, bond between carbon and hydrogen. Between carbon and hydrogen, you know there is, and this is sharing of electron leads to the formation of radii. This covalent radii only forms when the orbitals overlap. And then suppose there are two atoms which are not reactive. So helium. Now these two elements of helium with each other, but they stay close to one another. That is why they have very, very less force of attraction. These are known as van der Waals forces of attraction. These are called van der Waals forces. मतलब अगर दो आयंस के बीच में कोई बॉन्ड बन रहा है, कोई रेडियस बन रहा है, तो आप उसको कहेंगे आयनिक रेडियाई. अगर दो ऑर्बिटल्स के बीच में कोवेलेंट बॉन्ड बन रहा है, शेयरिंग ऑफ इलेक्ट्रॉन्स हो रहा है, then you will call it the covalent radii. And if there are only weak attractive forces, there is no true bond present, then they are called the van der Waals radius. Now, as you can see, in the case of van der Waals, the atoms will be the farthest apart, सबसे दूर होंगे क्योंकि weakest forces हैं. फिर आयनिक बॉन्ड्स में एटलीस्ट थोड़े से पास आ जाएंगे और कोवेलेंट बॉन्ड्स में बिल्कुल ओवरलैप कर जाएंगे. दैट इज व्हाई द ऑर्डर ऑफ दीज रेडियस इज दैट has the highest length, followed by ionic radius, followed by covalent radius. यही बताना चाह रहा है वो उस वाले कॉन्सेप्ट में. Moving on.
About the general trends in atomic radius. In S and P block, atomic radius increase in number of shells and decreases across a period due to increase in their effect. Across atomic radius decrease, then becomes almost constant and then increases at the end.
So as you move from left to right, you can see in the diagram also, atomic radius keeps on getting reduced because the shell is the same and the number of protons in the nucleus is increasing. This increase of number of protons gives strong toward to the electron. That is why it is decreasing. But in case of a period, because there is an addition of new shell altogether. Here there are two shells. Cesium में there are 7 shells. Here should be cesium, not calcium. So in case of left to right, the size decreases. On top to bottom, the size increases. Moving on. Moving on.
Ionic radius. Radius of an ion is called ionic radius. The radius of a cation is smaller than the corresponding neutral atom due to increase in Z effective. The radius of an anion is larger than the corresponding neutral atom due to decrease in Z effective.
So basically, we are trying to compare the radius of anions and cations. He is saying that in case of a neutral X, any atom X, this is the atomic radius. If you make the X positive of this, it will have a smaller size. Negative of it will have a larger size. Example, suppose my element X has 10 protons. In case of X positive, will now have 10 protons, but 9 electrons, because X positive formed means there is a 1 electron. Now, in the case of initially, protons were taking care of 10 electrons, 10 protons were pulling 10 electrons, but in case of the cation, what happened in the case of cation? There are larger number of protons, but lesser number of electrons. That is why the pull became stronger, size reduced. size became smaller than the neutral one. In case of anionic, what happens is that you again have 10 protons, but now you have 11 electrons. Now for each proton, there is more than one electron present. That is why the effective nuclear charge is not very strong. This leads to a greater size. So always cations have smaller size than their corresponding neutral atoms, who have further smaller size than their corresponding anionic atoms. Now let's ready everybody? All right, ready class 11th? We are playing the questions. This would be the last module, right? First question. Atomic radius decreases in the order van der Waals, then metallic, then covalent. True or false? Beta, metallic radius is the same thing as ionic radius. Okay, I am getting answers. Very good. Shubham, Gaurav, Aditya, Rati, Dumka. These are the names of kids who have answered correctly. Okay, Angel and Sonal, Lahul also. Dumka, where are you? Anupur, where are you? Arihant? True, everybody saying true. Very good. Absolutely, it's true. Then, more is the number of shells, smaller is the atom. Is this true? More is the number of shells. जैसे जैसे आप शेल इंक्रीज करते जाएंगे एटॉमिक साइज इंक्रीज होएगा या डिक्रीज होएगा? फॉल्स. एब्सोल्युटली करेक्ट. बिल्कुल सही बता रहे हो. जैसे जैसे शेल नंबर इंक्रीज होएगा एटॉमिक रेडियस भी इंक्रीज होता जाएगा. वेरी गुड डोंडी. फॉल्स. नाइट्रोजन एटम इज लार्जर देन ऑक्सीजन. Nitrogen atom is larger than oxygen atom. True or false? गलत. Say atomic number 8. Size becomes smaller. Hydrogen and then fluorine will have the smaller. The size कम होता जाता है. Size lower. Next, metallic radius larger than van der Waals. True or false? Metallic radius is larger. False or true? क्या दोबारा से? हाँ ट्रू. सही कह रहे हो. सही कह रहे हो. सही कह रहे हो. राहुल ऑल्सो सही कह रहे हो. Yes, this is false. As the Z effective increases, atomic radius decreases. जितना ज्यादा इफेक्टिव न्यूक्लियर चार्ज बढ़ता जाएगा एटॉमिक रेडियस कम होता जाएगा. सही बात है. बिल्कुल सही बात है. जितना ज्यादा इफेक्टिव न्यूक्लियर चार्ज बढ़ता जाएगा, खींचना बढ़ता जाएगा, एटॉमिक साइज उतना होता जाएगा. यस, वेरी गुड. सल्फर एटम इज phosphorus. दोबारा, सल्फर एंड फॉस्फोरस दे आर राइट नेक्स्ट टू ईच अदर. नाइट्रोजन के नीचे फॉस्फोरस, ऑक्सीजन के नीचे सल्फर. लेफ्ट से राइट जाने पर साइज लोअर होता है. पहले आएगा फॉस्फोरस एटॉमिक नंबर 15, फिर आएगा सल्फर एटॉमिक नंबर 16. साइज किसका ज्यादा होगा, सल्फर का या फॉस्फोरस का? बेटा शुभम प्लीज डोंट. True. True. Sulfur will have larger size than phosphorus. You are again getting confused. No children, no. False. Yes, Dondi. Bilkul. False. Next. Z effective in a cation is always larger than neutral atom, due to which the size increases. ध्यान से पूरा स्टेटमेंट पढ़ना. कैटायन में इफेक्टिव न्यूक्लियर चार्ज ज्यादा होता है न्यूट्रल से. बात ठीक है. सेकेंड पार्ट कह रहा है दैट इज वाई एटॉमिक साइज इंक्रीजेस. क्या कैटायन का साइज ज्यादा होता है न्यूट्रल से? फॉल्स. यस. अंबसा, वेरी गुड. यस, ट्रू. द एटॉमिक साइज एक्चुअली फॉल्स. परफेक्ट. क्या हो गई 90% एक्यूरेसी क्यों आई? अच्छा, एक नाइट्रोजन की वजह से. ठीक है, वेरी गुड. So far we have discussed some amazing properties. We have discussed the atomic radii. We have discussed the different forms of periodic table, and we have seen how did we reach to the periodic table. क्या क्या बातें कर ली हैं हमने आज? Dobernier's triad, Newland's octave, Mendeleev's table, modern periodic table, different blocks, group numbers, periods, valencies, atomic radius, metallic and covalent and van der Waals radius. We have seen all these things. In the upcoming lectures, one more class we will take and we will wind off this chapter. All right, some more modules are left. One more class we will take, Bacha log, and we will wind off this chapter. Till then, please revise till here from your NCRTs. All right, read each and every line of NCRT. Very important. NCRT is very important for this particular chapter. So please read each and every line of NCRT till atomic radius. And we will continue this chapter one more class in the upcoming week. All right. Bye-bye, EMRS class. And keep studying. Bye-bye, bacha log. Bye, everybody. Good evening, Dondi. Bye-bye. Yes, hole se, Nachar, hole se. So much for connecting, Rahul. Bye-bye, everybody. Take care. Bye, Angel and Sonal. Keep studying and take care. Winters are coming. Please take care of the weather. Don't fall ill. Thank you for connecting, Parinita from Rajnagar. I hope you were able to understand. Thank you for connecting, बच्चा लोग. EMRS Lafa, bye-bye. Dondi, you have been very responsive today. Dondi, आपके साथ बहुत मजा आया है आज. All right. Thank you for connecting, Parinita.